Hello everyone. From today, we are going to start a new math series that is based on CBSE and JEE math series. In this series, we are going to discuss all syllabus of CBSE and JEE mathematics, in which we are going to cover every concept in detail, and also we are going to do the questions in three different variants. First, textbook questions. Second, questions that will be based on CBSE pattern type questions that come in the CBSE board, and the third JEE level mathematics questions. So let's start. So today we'll start from the first chapter, that sets. So let us see first what is a set. So let's see first what is a set. Let us say we take two collections of objects. Let us say I take a collection 1 and collection 2. In the first collection, let us take I take the collection of first 10 natural numbers. Collection of first 10 natural numbers. In this second collection, let us say I take the collection of 5 most beautiful 5 most beautiful birds in the world. So we have two kind of collections. I take the collection 1 that consists of the first 10 natural numbers. I take the second collection that consists of the 5 most beautiful birds in the world. Now if we tell to any two persons in the world what are the first 10 natural numbers, we'll see that every person will take that the first 10 natural numbers are 1, 2, 3, 4, 5, 6 up to 10. And we'll see that between any two persons, there will be no contradiction that the first 10 natural numbers are from 1 to 10. Now, if we take the top of, now we'll talk about second collection, the 5 most beautiful birds in the world. If we tell about this collection to 82 persons, we'll see almost what will be the choice of one person. The choice of second person will there will be always possibilities that it will contradict with the choice of second. For example, if one person chooses A, B, C, D, E, the second person will choose some B, C, D, E, F, different words. So there's always possibilities that there will be a contradiction between two persons when they will choose the on their viewpoint what are the 5 most beautiful words in the world. So we'll see that in this kind of collection, there will be always a contradiction between two persons. While in this, there will be no kind of contradiction to any kind of person. We'll say then this kind of collection is set, while this kind of collection, it is not set. So we'll say that a set is a well-defined collection of objects, elements, or numbers. So if we have any kind of a collection that is well-defined, that is, there is no kind of contradiction between two persons, so related to that collection, so we'll say that that collection is set. But if the collection has some, if we take such a collection in which two persons have different views upon that, so we'll say that that collection is not well defined, and we'll say that's not a set. So now let us see how we represent the set, how we write the set. So let us see the next topic now, representation of sets. Representation of sets. Representation of sets. Sets can be represented or written by two types, by two methods. The first one is known as a roster form. In this form, what are the what are the elements in the set? They are actually written. Let us take, for example, I take a set, the set of first 10 natural numbers. So if I have to represent this set in a roster form, so what I do, I will just represent this set by some in capital English alphabet. That is, I take with capital A. So I will name the set with capital A, then write A is equal to, then I will use curly bracket and write the actual elements of this set. Since the set is the set of first 10 natural numbers, now I will write the first 10 natural numbers. 1. Between each element, I have to just use separate them with comma. 1, comma 2, comma 3, comma 4, comma 5, comma so on up to 10, and then I will close the bracket, and in this way this set can be represented in roster form. So what we do, so to represent a set in roster form, we first name the set by by any capital English alphabet. That is, I have here named by capital A, then I will equal to, I will use curved bracket, then I will write the actual elements in the set, separate them by commas, and then close that set by second curved bracket, and in this way this will be the representation of a set in a roster form. Let us take one more example. Right? Let us take another set, that the set of in English vowels, the set of English vowels. So let us represent them by any English alphabet. Let us represent them by B, capital B, equal to, now I will use the bracket and write the vowels, the English vowels. We know that the English vowels are five. They are A, E, I, O, U. I will close it, and this will be the representation of this set in roster form. Now let's move to the next form. The next form is set builder form. Set builder form, second form of representation of sets. In set builder form, we does not write the actual elements of the set, but what we do, we take a variable, and that variable represents the property of all the elements possessed by the elements of the set, and that property is not satisfied by any kind of element outside of that set. Let me take an example. Let us take an example. So how we represent it? We just first, let us say I have to represent the set in set builder form. The set is, I have to represent the set is I have to represent the set of English vowels. I have to represent the set of English vowels in set builder form. I have to represent the set of English vowels in set builder form. Now, how I represent them in set builder form? First, I will name the set by any English capital letter. Let us name with B. I will write B is equal. I will use curly bracket now. Then I will not write the actual elements. What I do, I will take a variable X. So I will write B is equal to set of all X, such that now I will write B is equal to set of all X. I have represented this set B, that is represented that the set is English vowel set. So for this, I will represent this set directly using the elements. I will just represent this set by a variable X. Now I will write the property, which property it represents, and this property is just represented by only those elements. So the B is a set of all X, such that X is an English vowel. So this X represents an English vowel. I will just close it. So without directly writing the elements, I just use an X variable, and this X, and then I just write the property. What is the property of this set? What is the property that is satisfied by the elements of this set, and that property is written after that by this X. So what is X? X is an English alphabet. We know that we have five English alphabets, A, E, I, O, U, which means that this X represents A, E, I, O, U, and in this way, and this representation of set is known as set builder form. Let us pick it in more detail by using second example. So look it in. So we'll just look this kind of set in more detail view by using the second example. Let us take I have to represent a set in cell builder form. The set is that I have to represent the set the set of elements from the set of all natural numbers that are greater than 3 and less than 11. I have to represent this set in set result form. So it's a set where the all the elements are natural numbers and all the elements are greater than 3 and they are less than 11. Less than 11. Elements are greater than 3, less than 11. So just we'll just represent this set by using the set builder form. So let's take by using the set builder form. Let us first take any English alphabet that will represent this set. Let us take capital C. So capital C is equal to set of all x such that now I will write the property. Now I will write the property that what this x is. Now we are given that we have to represent the set of natural numbers that are greater than 3, less than 11. Now write x set of all x such that x belongs to natural numbers. This x, it belongs to natural numbers. This x comes from natural numbers and x is greater than 3 and less than 11. So when I just expand this set, I will say I will get the elements 4, 5, 6, 7, 9, 10. So in this, though this representation is known as set builder form. So what we do in this representation, we just take a variable x and then define the property that is the property that is defined by the elements of the set using this x, and that property is not defined by any other element. So in this way we can represent the set in the second form is known as set builder form. Now let us take some property of sets. The first property is, for example, if I have to tell how to, for example, I have a set of first 10 natural numbers. Let us say the set is like this. Let us say set A is equal to 1, 2, up to 10. Now, I will be asked whether 1 is an element of set A or not. Yeah. So for that, how will we represent? We write it like this. 1 belongs to A. We write like this. 1 belongs to A. Let us say, for example, I have to check whether 7 is an element of this set A or not. We know 7 is because from 1 to 10, all the elements are elements of set A. So I'll write 7 belongs to A. Similarly, if I take 11, I know 11 is not the element of this set. So I'll write 11 does not belongs to A. Similarly, if I have to check 12, 20, so I'll write 20 does not belongs to A. So whenever we have to represent whether an element belongs to a set or not, we'll write 1. Let us take, for example, we take that element and write belongs to that set. Similarly, if the element does not belong to a set, we write that element does not belong to that set. So this is a representation. And now second thing. In second thing, we see that we have represented the elements in roster form. In roster form, we just write the actual elements of the set. But we have to remember two things. First, the order is not important. For example, if I am writing the set of first 10 natural numbers 1, 2, 3, 4, 5, 6, and 9, 10, so I can write them in any order. Order does not matter. And third thing, repetition elements, we don't repeat the elements whenever we write them in set builder form or in roster form. Let's take an example. Let us say, for example, I have to write the letters of the English word school. I have an English word school. I have to write this. I have to write its letters in a set. I have to just represent a set. So let us write in. Let us take set D. D is equal to set. So it will be S C H, and since we have two O's, I can take just single O and L. So here we does not represent the elements. We don't write the repetitive elements. We just write the one always in a in roster form. We just always write only the distinct elements. So this is the second thing. One more thing. So the fourth thing is that in we know that in mathematics we deal with number systems, and we have to remember that all the number systems are all sets. Let us discuss some number systems. We know first the number system. First, the basic number system is the first is n. N represents the natural numbers, so it's a set of all natural numbers. The second one is capital Z. It represents the set of all integers. Then we have capital Q. It represents the set of all rational numbers. Then we have capital R. It represents the set of all real numbers. Then we have Z positive. It represents the set of all positive integers. Then we have Q positive. It represents the set of all positive rational numbers. Then we have R positive. It represents the set of all positive real numbers. Then we have I. It represents the set of integers. So these are the some number systems. Similarly, we can have irrational numbers. We can represent by any number name. Similarly, we have complex numbers that we see later on. So these are the so in mathematics. So we are since we are dealing with all the number systems. So all the number systems are sets. I have to remember. Now for representation of sets, let's move to the types of sets. So let us see now types of sets. Let us discuss the first type of set, that is known as empty set. We just also name it as void set or null set. Void set or null set. So if a set does not have any element, we call such a set as an empty set. For example, let us take a set of all the students, set of all students in a school that read in both 11th and 12th grade. Set of all the students in a school that read in both 11th and 12th. We know that there it is not possible that a student is studying in two classes at a time. So it is not possible that a student is studying at a time in two classes. So we'll say that this kind of set is not possible. So we'll say that this is empty set. How we represent empty set? We represent by this phi. Phi represents empty set or void set, or we say null set, or we represent it with two curved brackets without any elements. Let us take another example. Let us say I have a set A is equal to set of all x such that x is greater than 1, less than 2, x is greater than 1, less than 2, and x belongs to natural numbers. Since x, now I have to tell what elements of x have. Since x is greater than 1, less than 2, and x natural number, we know that between 1 and 2 there is no natural number. So we'll say that this is a phi set. Similarly, we can take many examples. Let us take the second type of set, that is known as singleton set. A singleton set. Singleton set. A singleton set is a set that has only just one element. Let us have set A is equal to, let us say, I. So since it has just one element I will say it is a singleton set. Let us take any other example. Let us say I have a set B is equal to set of all x such that x minus 1 is equal to 0 and x belongs to integers. So it's equation Here x represents equation, and here x is an equation, and the set says that x such that x is a solution of, so set is a set of all x such that x is a solution of this equation and x belongs to integers. So when I just find solution x minus 1 is equal to 0, we'll see that x is equal to 1, and we know that x is integer and it has a one solution of 1, so we'll say that it's a second set, and the set will say that then set b is equal to 1. So a singleton set then is a set which has just one element. Let's move to next set. The next set is finite and infinite sets. Finite and finite and infinite sets. A finite set is a set that has certain number of elements that can be counted. Let us say I take a set A is equal to, let us say 1, 2, 3, 4, 5. Since it has a 5 elements, it is a 5, so I will say it is a finite set. I will write number of elements in A is equal to 5. Similarly, I will take set B. Let us say I take B is equal to, let us say 6, 12, 18, 24, 30, 30, 36, 42. So I will say that in this set, if I see how many elements are 1, 2, 3, 4, 5, 6, 7. Since I will say that the number of elements in B is 7. So n of B, number of elements in B is 7. I will say it is a finite set. So a finite set is a set which has a certain number of elements that can be easily counted. Now, if we have a set that has infinite number of elements that we cannot count, so we'll call that infinite set. For example, a set of all natural numbers. We know how many natural numbers are there. There are infinite number of natural numbers. So it's an infinite set. How many? Let us take the set of all integers. How many integers are there? There are infinite number of integers. We cannot count them. So we'll say all these sets are infinite sets. And for infinite sets, we have to remember one thing, that we cannot represent by roster form all infinite sets. We can represent, for example, if I take infinite set of, let's say I take one infinite set, let us say set of natural numbers, I can easily represent it with roster form. For example, if I take n is equal to, n is equal to 1, 2, 3, 4, so on. So these dots will tell us that it goes up to infinity. If I had represented integers, set of all integers, I can also easily represent. Let us say z is equal to dot 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 -3, -2, -1, 0, dot 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 dot, so on. So we can, in this way we can represent all set of all integers using roster form. But if I have take now set of all rational numbers, real numbers, irrational numbers, we cannot represent them with roster form. How? Why? Because we know that first, if I take any, let us say I take a set of all rational numbers. So let us say Q. We know now Q, it represents a set of all rational numbers. If I take any two rational numbers, let us I take 1, 2. We know that between these two rational numbers, there are infinite number of rational numbers. How can we write them? We cannot write them. So it means that it is not possible to write all the elements in a rational number set. So we cannot then write the rational numbers in roster form. Similarly, rational numbers, similarly real numbers. Because between two real numbers, we have infinite number of real numbers. We cannot write them all. So they do not form any kind of order, particular order. That is like the order is followed by natural numbers and integers. That kind of order is not followed by real number, rational number, and irrational numbers. So we cannot write their elements. So in this way, we cannot write them in roster form. So this was about the finite and infinite sets. Now let's move to next set, that's equal and equivalent sets. equal and equivalent set. If in two elements we have the same kind of elements, we'll say they are equal. Let us say I take set A is equal to 1, 2, 3, 4. Set B is equal to, for example, 3, 4, 1, 2. If I see that it has 1, 2, 3, 4, it has the same 1, 2, 3, 4. So I'll say that if the two sets have same elements, so they are equal. Now there's one thing. If the elements are repeated, let us say I take the set, let us say set C is equal to 1, 2, 3. Another set D is equal to 2, 2, 3, 1, 1, 1. Since it has three elements, 1, 2, 3, it has 1, 2, 3, 4, 5, 6 elements. But the distinct elements are same. It has 2, it has 2. It has 1, it has 1. It has 3, it has 3. So I will say that these two sets are equal. So because in sets, we don't repeat the elements. We write just only distinct elements. So these two, they will actually will be only 2, it will be 3, and then there will be only 1. So it has just 3 elements because we don't repeat the elements in a set. So I will say that these two sets will be equal. Now we'll say now let's move to equivalent sets. Two sets are equivalent if they have equal number of elements, but the elements are not same. Elements will be different. For example, I have a set A is equal to 1, 2, 3, 4, while I have a set B is equal to A, B, C, and D. They have four elements. Number of elements are same, but the elements are different. So I will say that these two sets are equivalent. So equivalent sets are those sets which have same number of elements, but the elements are not same. While the equal number should be same and elements should be also same. So we'll say them equal. So this was about equal and equivalent sets. Now let's move to another set that is known as indexed family of sets. Indexed family of sets. Indexed family of sets. So for this uh, to go for this set, what we'll do, let us take an example. Let us say we have a colony. Let us say we have a colony, and in this colony, let us say there are 100 houses. 100 houses. And the members of one house, they are represented by AI, where I is greater than equal to 1, less or equal to 100. If I take A1, A1 means is the first house, and this set will represent the members, the names of the members of the family. If I take A2, it will represent the names of the members of the family in this second house. If I take A3, similarly, it will represent the names of the members of the family in the third house, similarly up to 100. Then I can say that these 100 sets from 1 to 100, from 1 to 100, I will write them by another name, set A, and this A I will tell is a set of all AI such that I is greater than equal to 1, less or equal to 100, comma, where AI represents names of members in a house. In a house. So in this way, this set now, set of all these 100, this set A, it consists of 100 sets. It consists of 100 different sets, and these all 100 sets, will say they are known as indexed family of sets. So in the index family of sets, we have more than one set. We have more than one set, and they can be combined in a one family that is known as an indexed family of sets. So this was about indexed family of sets, and from now we have the subsets, and we'll start the subsets in the second lecture in the next class.